we are on page 2 of Ellipses, and we're going to talk about this one where it has a center at HK. And the actual formula changes a little bit, but it's very similar to doing the circle. Okay, so our general form of an ellipse at any center is going to be x minus h quantity squared all over a squared plus y minus k quantity squared all over b squared equals 1. All right, and in this case again we're saying that a is bigger than b, so what's my major axis going to be on this one? The x, so it's going to have a horizontal major axis. Again, whenever that is the case, you're going to have c is equal to the square root of a squared minus b squared in order to be able to relate a, b, and c together. And what we're going to do is go down that first column. We're also going to draw in our ellipse down at the bottom where it has our little axes there. That's a terrible axis, but there it is. Okay, we're going to draw one in there. I guess the first thing we ought to put is our center. Let's just put a center in. We'll call that HK. All right, our center will be HK. And then I'm going to have a focus. So let's put in a focus here. And we'll put in one here. And then it's just going to be equidistance from those.
Hi, Daddy. How are you?
Okay, so far so good. Dotted line just to label my major axes. Okay? Major axes. That's the whole thing. Your major axis is from vertex all the way to vertex. The distance of that is 2a. So one of these puppies would be what? How long? Just a. Yes?
Mm-hmm.
Okay. Should we put in another color? I think we shall. Just for
yes.
How long is this little puppy here?
B.
B, because it is your
Minor axis.
Minor, right. Now, when they say semi, like semi-annually, twice a year, right? They cut it in half. All right, so they'll call this the semi-major, semi-minor.
Or semi-truck.
Or semi-truck, exactly. What is my distance from my focus to the deal? It's C. Okay. Okay. So we have C, we have B, we have A, we have something that relates A, B, and C. Now we're going to say what the focus and the vertices are actually equal to. So let's just take a look here. If you're looking at just the focus right here, okay, my center was HK, and I'm adding what distance here?
You're adding
C, and I'm adding it in the horizontal direction, right?
Mm-hmm.
So my focus is going to be located at H plus C, comma K. So what's this focus going to be located at? H minus C?
H minus C, comma K.
Comma K? Okay. And my vertex is going to be at H plus what? A? Because I'm A over, or H minus A, comma K. Is that good? Mm-hmm. So these are my vertex. This is my focus. I think we're all good there. And the cool thing is the H always goes with the X. The K always goes with the Y. Whichever one's bigger underneath the A squared or the B squared, that's going to be your major axis. So you can tell just by looking at it whether or not it's going to have a horizontal major axis or a vertical major axis. All right? Can I take a break and call for a minute?
There.
Now I'm working?
Yep.
Okay, now we're working. Okay, we are on the ellipses. We're on page 2. We're doing the second column. In this one, it's the general form of an ellipse, x minus h quantity squared. This time it's over b squared, which means that our larger number is going to be under the y minus k one. And wherever the larger number is under, that's going to tell you what your major axis is. So my major axis is going to be vertical here. So the first thing I'm going to do is I'm going to put in a center, and I'm going to go ahead and label it HK. And then I'm going to go ahead and put in some focuses, foci. I should probably say that right, being the teacher. And then we'll try to draw one of these puppies. Okay. So the distance from the center here to a vertex is going to be A. This is your semi-major axes. Okay? And let's see, what else? We need our minor axis length, okay, which would be from the center to the edge on the minor axis, which this time would be horizontal, and that length would be B. And then your distance from your focus to your center is going to be a distance of C. Are we okay with that?
Mm-hmm.
This up here is a vertex. This way down here is a vertex. And we want to label the actual points for our vertex and our foci. So let's look at this one right here. My center was H comma K. I didn't do anything in the X direction, only in the K direction. So this is going to be H comma, what is that? K minus A. And then up here, I'm going to have H comma K plus A. So far, so good on that one?
Mm-hmm.
And then it looks to me like I need to do this focus right here. And where is it going to be? It's still going to be at H, and then K minus C. And then up here, H comma K plus C. Does that look pretty reasonable for you guys?
Mm-hmm.
All right. Again, the key points to an ellipse, you're going to have a plus sign in between. It's going to equal 1. Okay? You find these equations the same way we did with the circle, which involves completing the square. All right? We're going to fill in what we have at the bottom there, which is under eccentricity. Again, we're not going into lots of detail about eccentricity, but we are talking about what eccentricity sort of is. Of an ellipse, your eccentricity is equal to C over A, and it will always be between 0 and 1. Okay? If the eccentricity is close to 0, it's fat and almost like a circle. Okay? The closer it looks to 0, which is the closer it looks to a circle, the closer it is to a circle. The closer it is to 1, it's going to look really long and thin. Okay? I don't even know what I would compare that to, but you know.
Someone with the mumps, or someone
Yeah.
who's
A funny
acting
mouth,
like
the
a
funny
goldfish.
mouth on the little handsy thing.
Yeah.
Okay, like that guy there.
This concept
roll.
is just insane.
Okay. All right. Are we okay with that?
Mm-hmm.
All right.
Eccentricity.
Beep. Turn the page. We're on page 3. So we're going to close that down. Brendan.